Hello everyone, welcome back to this channel. We are studying class 11 physics, in that chapter number 4, motion in a plane. So today in this video we will study the equations of motion. In fact, we will derive the equations of motion again, but this time in two dimensions. That means in plane, right? Now before that, till now in previous chapters we have derived three equations of motion that I hope you are all knowing it. But now there might be two changes. That first of all, we will have all the equations in two components, that is x component and y component, and there will be a vector symbol in all the physical quantities. No doubt the equations will remain the same. So starting with the necessary assumptions, that is, suppose a particle moves in the xy plane. So we will write the necessary things. The particle moves in xy plane with uniform acceleration. With uniform acceleration, that will be a vector. Now velocity at time t. So we'll write at time t equals to 0, velocity will be v0. Okay, and at time t equals to t, velocity will be v vector. So initial velocity and final velocity we have got. Now as it is moving with uniform acceleration in any time interval, its average acceleration and instantaneous acceleration will be the same. So if we find the change in time and change in velocity, that is change in time delta t, it will be final time minus initial time, that is t only. If you want to find out the change in velocity, that is delta v vector, that will be final velocity minus initial velocity. So now let us go for the formula of acceleration. So over here acceleration a vector will be delta v upon delta t, and that will be putting the values of delta v over here, v minus v0 upon t minus 0. So that will become v minus v0 upon t, and over here we will write vector of acceleration. Now if you cross multiply it, it will become a into t equals to v minus v0. Changing just the position of few components, we will have the final equation v equals to v0 plus a into t. So this is our equation number 1, equation of motion. But we will write the same in terms of its components. So now this is the velocity, initial velocity, final velocity, acceleration. But if we want to find out the x component of velocity, that will be written as vx, and everything will be now according to x. So here the position will be as per x, plus here the acceleration will be towards the x direction. Clear? Same way, vy, even if you want to find out the magnitude, don't put the arrow, y will be v0y plus ayt. So why we are going for this? Because in case in numerical it is asked that find the magnitude of velocity in the x direction, so we will only use this formula. If they have asked in y direction, we will only use this formula. So this was all about the first equation of motion in two dimensions. Now let us go for the next one. Now for the second equation, we will again have to assume few things, like at time t equals to 0, the position of object at time t equals to 0 is determined by r0 vector, and at time equals to t, the position is shown by r vector. So these are nothing but position of the particle. Now if you ask about what will be the average velocity over this time. So average velocity will have two formula as we have discussed earlier. It is change in displacement. Velocity is displacement upon time, and it also has another formula, that is the average of final velocity and initial velocity, right, divide by 2. So now if we compare these two equations, it will be like this: r minus r0 vector upon t equals to v plus v0 upon 2. So take this t on the other side. So what it will become? It will be r minus r0 equals to v plus v0 upon 2 into t. Now quite a few replacements that we are going to have in this equation. So here it will be r minus r0. Now what we will do, we will replace the value of v from the first equation. And what was v? V was nothing but v0 plus a t, and v0 we will combine all the terms that we are repeating will be written like this. And also what we can do is to add the v0 and v0. So now it will be r minus r0 equals to 2v0 plus at. Over here we have t upon 2. Now we will have to do two things simultaneously, is that t will be multiplied to each of the terms, and then 2 will be given to both the terms. So this will become r minus r0 equals to 2v0 t upon 2 plus at square upon 2. And we all know that how to write this. 2 will be cancelled over here, so we'll only have v0t plus half a t square. So this is our second equation. But don't forget that we have r minus r0 over here. So the final form of this equation will be r equals to, r0 will take over here, that is r0 plus v0t plus half a t square. So final form of the second equation is like this. Now what about the components? We still have to split this into its components. So what we'll have to change? We'll just have to replace r, v and a by x and then by y. So this is how it looks like: x, x0, v0x, ax. This will be along the x-axis, so this will be the x component, and y, y0, v0y and ay will be along y-axis. So this second equation of motion can be written in two different ways, in terms of x component, in terms of y component. Note that all the necessary values might be given if you are solving any numerical. Now moving on to the third and the last equation. Now for equation 3 we will be utilizing the previous few equations that came in these two derivations only. For example, a equals to v minus v0 by t, r minus r0 by t equals to v plus v0 upon 2. That was for average velocity. So t I have taken on this side. So now what we will do, we will have to multiply these two equations. So left hand side with left hand side, if we multiply, that will be a into r minus r0 is equal to, over here we have v minus v0 upon t into v plus v0 upon 2 into t. So what will happen over here? We can cancel this t and t. So now the final form of this equation will be, if you take this 2 on this side, 2 will go on this side, so it will become 2 into a vector into r minus r0, and applying the mathematical identity, that is v minus v0, v plus v0, that is a minus b, a plus b. So that becomes a square minus b square. So this will be our third equation. This just looks like 2as equals to v square minus v0 square. So this will be our third and the last equation. So I hope these steps were easy for you. I told you before in the beginning that the equations will remain the same. The difference is just we have divided the equations into components x and y, and then we have put the vector symbol over here. The rest, the process is same. So that's it for this video. Thank you.